You manage the Azure infrastructure described in the table below. The table shows 3 columns: name, type, and description. Row 1. VNet 1. Virtual network. Connected to an on-premises network via ExpressRoute. Row 2. VM1. Virtual machine. Acts as a local DNS server. Row 3. SQL DB1. Azure SQL Database. A standalone instance. Row 4. PE1. Private endpoint. Provides private access to SQL DB1. Row 5. Contoso.com. Private DNS zone. Linked to VNet 1. Contains an A record for PE1. Row 6. Contoso.com. Public DNS zone. Holds a CNAME record for SQL DB1.
You must design a name resolution strategy that allows the on-premises network to reach SQL DB1 using the private IP associated with PE1. Select the correct configuration for each component. Option A, VM1 forwards contoso.com to the public DNS zone. Option B, VM1 forwards contoso.com to Azure provided DNS 168.63.129.116. Option C, VNet 1 uses a custom DNS server pointed at 168.63.129.116. Option D, on-premises DNS forwards contoso.com to VM1. Option E, on-premises DNS forwards contoso.com to the public DNS zone. Option F, on-premises DNS forwards contoso.com to 168.63.129.116.
In my view, the correct answers are option B for the Azure configuration and option D for the on-premises DNS configuration. To enable on-premises connectivity to an Azure SQL database via a private endpoint, the on-premises DNS must resolve the database FQDN to the private IP of the private endpoint.
Since the private DNS zone containing the A record for the private endpoint is only resolvable within the virtual network via the Azure-provided DNS IP 168.63.129.16, an intermediary is required. By configuring the on-premises DNS to forward queries for contoso.com to VM1, the request reaches the Azure-based DNS server. VM1 is configured to forward those specific queries to the Azure-provided DNS, which successfully resolves the private IP address defined in the private DNS zone.